Yeah. So I can do another screen share here, and I can show kind of the sequence we were describing before.
Oh, okay,
about
good.
The generation of the polygons. Here, we'll do this. And
yeah, so while you're pulling that up, I just want to say, like, we live in an area that it's the Edwards Plateau. It's very eroded. So when I look at it on a satellite map, there are clear erosional patterns, and you can see them when you're looking down at it from a satellite map or whatever. But living in it, I would never pick those patterns up, like just driving around it or walking around in it. It's basically, or looking out at it, you see hills, and it seems random. But as soon as you get that above view, you understand, oh, there's a huge erosional pattern here. It's just almost impossible to grasp it from the ground without doing a lot of surveying work and mapping, basically.
Yes.
Yeah.
And that's why now I supplement when Bradley and I are traveling. We're all of our expeditions are prefaced with a lot of map work, a lot of aerial photography, a lot of satellite photography, and so we've had that preparation, so we kind of can get that picture in our mind as we're traversing these landscapes with a more limited perspective.
Yeah.
All right. Do we see this image?
Yes. Entry into the realm of sacred geometry. Yeah, we see it.
Yeah, it begins with a circle, right? The simple act of putting a compass to paper, or putting your pole into the ground and drawing that circle around it. And this is what I was talking about before. The radius of a circle exactly divides the circumference of the circle into 6 equal parts. So you'll see there that you've just basically, you could start anywhere in the circumference, step off one increment. It's going to be 1/6 of the way around the circle. And then if you draw radial lines from the center and connect them, you end up with an equilateral triangle. And then if you step all the way around the circle, you end up with a hexagon. And you can divide that up and you get, your 6 equilateral triangles. And then if you connect alternate vertices, now you end up with the 6-pointed star, the so-called Seal of Solomon. And of course, now you can generate from that an infinite number of other polygons inside that, the hexagons. See, I could do another hexagon inside this one. I could, by projecting the sides out, I can create, see, if I project this side out, this side out, where they meet will give me the points of another star out here. So once I've got my initial hexagon, I can expand it or I can contract it. I can expand it to infinity in theory, or contract it to infinity to theory. Now, of course, in the real world, I'm limited, right? But,
well, you don't have infinite paper? Come on.
Not yet. But in the theoretical world, yeah, we can go. In the conceptual world, now, if you draw 2 circles of the same radius overlapping, now this is the doorway into the whole realm of geometry right here, because you've got, the point here is that you draw one circle and then you draw a second circle, but the second circle, two criteria here, has to be the same radius, and the center of the second circle can be anywhere on the circumference of the first circle. And then you're going to get the overlap like you see here. And once you've got that overlap, you connect the line of centers and the 2 intersecting points of the overlapping circles, and now you have your right angles.
Yes.
And see, from that, now what I've done is I've inserted a circle in there, the quartering of the circle. Inserting a circle inside the vesica, which this figure here, by the way, this lozenge here is called a vesica. It's also it's called a vesica piscis, or vessel of the fish. And so it's the vesica, it's related to the word vessel. And what is a vessel?
A container?
Container. Yeah, and what else does a vessel do?
It moves things, perhaps.
Yeah, it does. It does. It moves things. Here, I've got my good old dictionary right here, and it says that a vessel it's a hollow utensil used as a container. It's also a craft.
Oh, yeah.
Yeah, a craft
A ship.
designed to navigate,
Yeah.
especially on water. Also an airship. That's interesting.
I've wanted to ask you, you say vesica piscis. Is that the same word as Pisces? Or
Yes.
Okay.
So it's the vessel of the fish.
Okay,
Yeah,
okay.
that symbol is like, the way you would draw the symbol of the fish
yeah.
that's used in the Christian tradition.
Yeah. Flip it on its side, add a tail and a fin and an eye, and you got
All right.
you've got ichthys, the fish. Okay, so now I've drawn, notice what I've done here. The next step is I'm setting the radius of my compass to this half step here. Notice my original radius is this whole line of centers. But my fixed limb of the compass on the crossing of these two lines, and then I draw a circle within the vesica. And so now what I've got is my quartered circle, which basically is this universal symbol, which represents the fundamentals of geography.
All right.
So notice when you've got here, we've got time and space coordinated with this quadrature of the circle. So we've got in the annual cycle, we would have winter solstice, spring equinox, summer solstice, and autumn equinox. In the diurnal or daily cycle, we'll have midnight, sunrise, noon, and sunset. And then in the cardinal directions, we'll have north, east, south, and west. Now, notice winter solstice. Here's our scale invariance again. Notice the correlation between annual cycle and diurnal cycle. Winter solstice corresponds with midnight and north. Spring equinox corresponds with sunrise and east. Summer solstice with high noon in the direction south. And autumn equinox with sunset in the direction west. So you want to begin to kind of integrate these ideas into your mind and these correlations.
Okay, so a lot of times the ancients would, cite in, say, one of the zodiacal constellations using either the sunrise or the sunset, right? Which constellation that was where the sun was rising or setting on the spring or autumn equinox. Is that why they would pick sunset or sunrise? In other words, if you're doing it on the autumn equinox, you would do it during sunset, as opposed to the spring equinox, you would do it during sunrise?
I don't know.
That's a good point.
I don't know. I mean, if your idea is to try to get the heliacal rising,
right, that would be sunrise. Yeah,
star or constellation. It was usually done at sunrise.
Right.
So you would observe the sky to see what showed up on the horizon, what rose on the horizon, on the eastern horizon, just before the sun.
Right.
And I think that, extended observations over many, many centuries, would begin to disclose the fact that that the stars were drifting.
Yes.
And so that, the stars that were showing up heliacally or on the horizon just before the sun rose would change, and that change would be observable over a span of centuries.
Right.
In fact, the change over 72 years, which is basically a human lifespan, would be one degree on the ecliptic.
Yeah, that's not a lot to know. You have to be really paying attention to notice that.
Yes. Now, to get some sense of 1 degree on the ecliptic, a full moon is a half a degree.
Yeah, that's.
So if you can think of two circles, two full moon circles tangent to each other in the sky, that would be 1 degree. So notice here that the moon is kind of defines first in its own orbit 360 degrees and 720 segments of half degrees. So right there, you've got 360 and 720 that nature has basically given us.
Yeah. Wow.
So one full moon is 1/720th of its distance, its orbital distance.
How did that happen?
It's all coincidence.
All right.
So the sun is essentially the same, right? It's a half degree. I mean,
Well, yes. So the orb of the sun, right. And so when the sun is rising or setting is when you can actually visibly look at it without burning your eyeballs. Pretty much it's going to be at a half a degree. Now, of course, there's variations because you've got perigee and apogee, right, which is when the moon is closest to the Earth and when it's farthest away. So the moon varies. At perigee, it's about 221,000 miles from the Earth. At apogee, it's about 252,000. So obviously at perigee, the moon is going to look somewhat bigger, and at apogee, it's going to look somewhat smaller. And likewise with the sun, because the Earth's orbit around the sun is not perfectly circular; it's elliptical. So
Yeah,
right.
The average though works out to be very close to 93 million, but at perihelion, it's a little closer, and at aphelion, it's a little farther away. So.
And also there's atmospheric lensing, which can result in when it's on the horizon, it looks enormous, right?
Yeah. What's important here for people to understand is that, it's just like in any set of architect's plans, you're looking at a theoretical ideal.
All right.
And no matter how skilled the craftsmen that then now execute the project, there's going to be some variation, some deviance that enters into the real world execution of the idealized theoretical pattern.
Right. So basically what you're saying is God was like, well, it looked good on paper.
Well, so God is working from a geometric template, but then in the execution of the real world, there's going to be variation. And see, again, that gets back to what we were talking about between this symmetry between order and chaos, see?
Yes, right.
Because there are these little deviations introduced into the system. You've now introduced chaos into the system.
Right. And the chaos allows for there to be change over long periods of time, for sure.
Yes.
Yeah.
It allows for a dynamic system during which life can arise.
Yes.
Otherwise, it's just going to be dead matter. And here, in the next image, is that quartered circle laid onto the ground.
Oh.
This is a really cool exercise here. You lay out the quartered circle on the ground and you get a chair and you put right at the intersection and then you sit there. In the northern hemisphere, we would look to the south. And then you sit there in that chair for 1 year.
I can do that. Hey, I can do that.
Well, you would have, Russ, you could do that. And then Kyle, you would bring him lunch every day.
Yes.
Yeah, and make sure he's fed while he's sitting there for his whole year.
Just coffee.
I just need coffee. I'll be fine.
Okay. No, you wouldn't. Actually, Russ, you wouldn't have to sit there the whole time. You could get up and leave from time to time, but you'd want to come back.
Right.
So what you're seeing here is that you'll see summer solstice. You're looking to the south. The line that would picture where the line, you've got a north-south line, and then at right angles to that, you've got an east-west line. So look at that north-south line where it intersects the circle at south. Now picture a circle, an arc coming up in the z-axis that arcs over to the zenith and then down the other side.
Okay, yeah, I see it.
Okay, and so now the winter solstice sun, the equinoctial sun, and the summer solstice sun are all going to be arrayed on that line, which is the local meridian line, right? So this is your meridian here that you're seeing, and the meridian line would extend from it would start by coming up from the horizon due south, and then it would pass over the zenith. Now, what's the zenith? The zenith is the point in the sky that if you set up a plumb bob, right, one end of that plumb bob is pointing to the center of the earth, right?
Right.
The other line, if it was a vector, it would be pointing to the apex of the celestial dome, which is the zenith.
Okay.
Now, the zenith is a local phenomena. So my zenith right now in Georgia is not the same as your zenith in Texas.
Right.
You would be looking at a different point in space than I would. But relatively speaking, it would be the point directly overhead. So if you can picture this line coming up from the horizon due south, passing over your zenith, and then arcing down and touching the horizon at due north, everything is measured off your local meridian, right, east and west. And so you've got your hour lines, which are each 15 degrees, measured left and right of that. You see? Now, what they've done for the geographers have done is they have lined up the local meridian with the Greenwich meridian.
Okay, right.
See, so now they've kind of standardized the system. So if you really wanted to get the full effect, you would need to go sit in Greenwich, England, and with your chair.
I'm down.
That's too
You're
far.
down, man.
Too far for me to bring coffee.
Yeah, man, let's do it. We need a field trip here. They'll probably be wondering what we're doing there.
Why has that guy been sitting in that chair for like 8 months?
I'm thinking we could probably get a sofa
Yeah.
up there, because you might want to take naps. And
Yeah, give me a nice recliner. It'll be great.
Yeah. So okay. So now looking at this, you can see the summer solstice, the sun's way up much higher in the sky than it is at the equinoxes and the winter solstice. Now, there are one winter solstice per annual cycle, one summer solstice, and 2 equinoxes. So you'll also notice that if you follow the path coming up from the east for the summer solstice arc, that yellow line comes up, passes through at high noon. It's going to be due south, right? And then it's going to arc around and it's going to set in the west. Now notice winter solstice, it's basically doing the same thing, but notice how much shorter the path is.
Right.
Right? So right there, graphically, you can see why summer solstice daytime is much longer than winter solstice daytime.
Right. It's the circle that the sun is describing. There's much more of it above the plane of the ground there.
Yes. And then, of course, at equinoxes, they're going to be precisely the same.
Right.
Now, equinox, most people think equinox, today is the day of the equinox. But really, it's not a full day. It's just a moment. It's a mere moment in time that has actually no duration at all. It's simply a moment, right? But obviously, for the real world, I always say, well, narrow it down to a second or two, because that would be, you could realistically measure the equinox to within a couple of seconds of the actual moment. But, it's kind of like Zeno's paradox. It's kind of like fractals. If you took that 1 second and microscopically zoomed in on it,
yeah,
you see that the moment of equinox is just an infinitesimally small part of that.
Right.
See? But we don't need to go there, because we're living in a 3-dimensional real world of time and space. So if we can get it within a couple of seconds, hey, we're good, okay?
Right. But those couple of seconds are they going to be at noon, or are they going to be at sunrise?
Well, it depends, because that would all depend on where you are. See, what would you have to do is find the exact point on Earth to be. For example, if you wanted that moment to be exactly due south, you need to be at the right place. And I've figured that out. I don't remember exactly where it is. But, that point moves. So if you were setting your chair up to look at the moment of equinox, when it crosses the local meridian on to the south,
like at high noon,
the next year you would have to move your chair a little bit. Actually, that is if you were going to sit there for multiple years. Now, if you wanted to sit there for an entire lifetime, you could get a good sense of the precessional motion.
Okay. So Kyle and I set up on the equinox, we set up a transit And right at dawn, we sighted the transit in, and we decided that was the east. That was the east-west line, and that's wrong. Basically, it's not quite accurate. Is that's what you're saying?
Yeah.
What did you sight on?
So on the equinox, we set up a transit, and when the sun came up over the horizon, right when it touched the horizon on the equinox, we sighted the transit right at it, and we drew that as our east-west line. And you're saying that that's going to be a little bit off.
It's going to be a little bit off, yeah.
Dang it!
It is going to be a little bit off because, see, you were on the day. See, so you were there and did it at sunrise,
Right?
But the moment of equinox didn't necessarily coincide with your local sunrise.
Right.
Yeah, see, I was baffled because I came back at sunset, and all I had to do was flip the transit over to point the other direction. It's just a simple, just flipping the
sighting scope.
scope
Swing
over.
around 180
Yeah,
degrees.
and the sun's setting, and it's not in line. And I was like, what's the deal? But now I think I understand.
Yeah.
Yeah, I can imagine that would have been pretty disconcerting.
Yeah.
We were like, what's wrong with the universe?
What's wrong with the universe? The universe is effed up.
That's right.
Yeah, well, that partly explains it. Also, the fact that, undoubtedly you weren't in order to do this with a high degree of accuracy, you'd have to be on an absolutely dead level plane.
Right, which that was the idea that I basically blamed it on the fact that the possibility that the elevation over there where the sun rose
was
different from the elevation where I saw it setting.
Yeah.
Yeah, and yeah, that I'm sure that was probably the major part of it, actually.
Okay.
And it's amazing that even, when ground, the land looks level, it may not be level at all. I mean,
Right.
I'll get out, we're laying out a project right now for a new building, and the owner, the guy comes out there and he's thinking that it's, oh yeah, well, it's a pretty level site. But then I showed him, well, over 30 feet, it drops 3 feet.
Yeah.
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 So what I was trying to explain to him is why we couldn't, well, I was saying if we're going to do this on a slab, we're either going to have to fill up 3 feet on one edge or excavate 3 feet on the other, or some combination of the two. And he was, well, what? Is it that? So I took him out there and we pulled the level line and showed him that,
Yeah. It's hard to see it. Yeah.
Yeah, we're on grade up here, but 30 feet away, it's 3 feet down.
Yeah.
So he goes, oh, I see. That's why the foundation is going to cost that much.
Right. Yeah.
Yeah, that's exactly.
So now I want to go out there to our site where we did this thing with the transit and try your sun pole shadow trick and see how off our east-west line is.
Well, and here's the thing: your east-west line is going to be a little bit off too.
Oh,
Yeah, because you see, here's the thing: in the say the 8 hours or 9 hours, 10 hours, whatever it is, and it's going to be depending on what time of year you do it too. But the span of time between those two, remember, the Earth has now been moving.
Oh yeah,
18 miles per second around the sun. So that's going to throw you off, because now the Earth is going to be, let's say you do 8 hours. Well, 8 times 3,600 times 18, the Earth has now moved over 500,000 miles.
Right.
In those 8 hours.
Well, how did the ancients do all these? How did they get it all so precise? Like that the Great Pyramid is so freaking precise on the cardinal points. They must have.
Well, you would just have to do. You would have to make multiple observations and then interpolate.
Okay. Yeah.
That's how you would do it.
You have to do it a lot. Yeah.
Yeah, you would do it more than once. And like the method I was describing for the for finding the north axis, you can get that pretty damn close. If you can picture what I'm saying, I have a graphic somewhere. It may take me a few minutes to find it and pull it up. But basically, again, imagine that you've got this something that looks like a goal post, and the horizontal bar, you've got a plumb bob hanging from there, and then you use that, and then you sight against the North Star, right?
Right. Okay. Yes.
Okay. So now you get a foresight in front of it. So you've got 3 points: the observation point, the plumb line, and the North Star. And you get that exact line. You put a stake in the ground there. Now, 12 hours later, the North Star is going to have gone through half of its circuit around the exact celestial North Pole, right?
Yes.
So you take a second sighting, put a second stake in the ground, and now what you do is you split the difference between those two.
Right.
Because one stake represents a line tangent to one side of the arc. The other stake represents a tangent line to the other side of the arc.
Right. So you'd have to do this. You'd have to do this near the winter solstice when you have more than 12 hours of darkness, so that you can see the North Star over a long period of time.
Well, actually, what you would want is as close to 12 hours as you could get.
Right. I'm just saying so that means you need 12 hours of darkness, which means you need a long night. Yeah.
Exactly.
Yeah.
Yes. That would be exactly right.
Man, that's cool. I need to try both of those up on our Hill Hinge project.
Yeah.
Well, yeah, and so it'd be interesting. Now, I've never done the North Star thing, but you could certainly. It wouldn't be hard to do.
Yeah,
I mean, it conceptually, it's pretty straightforward, and it's just a matter of a little bit of trial and error to get your ideal sighting positions and so on.
Right, and then make sure that you have a night that's where no clouds move in and obscure anything.
Right. Yes. Right. Exactly. So,
Well, thanks, man. We're going to have to go rip up our Hill Hinge project.
Yeah. We've been building this giant Hill Hinge project based on our faulty freaking measurements of the east-west line, and now we're going to have to start over.
Well,
But we want future archaeologists to think we knew what we were doing, so we need to do this right.
yeah, even if you don't know what you're doing, you want to try to give the impression that you do.
Yeah, we definitely need to give them the impression that we freaking knew what we were doing. Yeah. And that we had lasers. They need to try to figure out how they did this without lasers. So
Yeah. Well, yeah, we can do lasers now. We have technology, so we don't need to use but it's fun to do the old techniques.
right.
And really, you can refine those techniques and get them to be extremely accurate.
Yeah.
So that's kind of the idea there.
Man. Well, I think we got a lot of Snake Bros, Snake Force people out there. I would encourage anybody out there to try these techniques. I mean, especially the one with the pole in the ground in the shadow. That sounds fun, and it's pretty easy.
Yeah, when you're laying out your garden, just do that first, and then you can, I don't know, a temple garden.
Yeah, make it fit the shape of the universe, and at least point in the right direction. So,
yeah.
Well, Randall, this has been fantastic, man. Thank you so much for coming on for episode 108. Really appreciate it.
Is this the end of it now?
Not quite.
I mean, not quite the end.
Okay, not quite. Well, maybe we should talk about a little bit more.
Yeah.
You wanted to get into some numbers.
I would. Yes, let's get into some numbers.
Okay.
We're going to go long.
We'll go a few minutes over.
Yeah, and then we're going to talk about the podcast. So you already mentioned it once. So let's do some numbers, and then we'll talk about the podcast.
No, okay. Yeah, so we won't get into any gematria tonight, or gematria. Magic squares, which are always fun. You guys ever work with magic squares?
No.
I don't know what that is.
Yeah.
Okay. Well, we'll look at one. This is the magic square of the sun. People might get a kick out of this, or they might go away concluding we're a bunch of Satanists.
Either one I'm fine with.
Okay. Share.
Ah.
There's the magic square of the sun. Get your calculator handy, Kyle?
I do.
Okay, let's just take the top row. And what I want you to do is I want you to add up the numbers 6, 32, 3, 34, 35, and 1 across the top row.
Okay.
and tell me what you get.
35 plus 1. 6 plus 32 plus 3 plus 34 plus 35 plus 1 equals 111. 111.
Oh, okay, so let's do the left-hand column going down. 6, 7, 19, 18, 25, and 36.
25, 36.
111.
Again.
I tell you what, let's try the diagonal. 6, 11, 16, 21, 26, 31.
21.
Oh, 6, 11, 16.
21, 26, 31.
31. A 1, a 1, 1.
Again.
Pick a row or column at random that you haven't done.
All right, do 25, 29, 10, 9, 26, 12.
111.
How is this happening?
It's because it's magic.
How are these? But
and this is called the magic square of the sun, and it was used by, shall we say, magicians and occultists and ceremonialists from the Middle Ages through the Renaissance. They were used in these rituals and ceremonies. Now, would you agree? Would you accept this on faith if I said if you added up any of the 6 rows across, you're going to get 111?
Yes. I think you
try 7, 11, 27, 28, 8, and 30.
7.
Do it. I'm going to do it. 7,
11, 27,
7,
28, 8, and 30.
111.
Yeah.
Tis.
Okay, now here's where it gets interesting. If you agree with me that every row across equals 111, or every column down equals 111, you've got 36 numbers, right? Think about this now. If you've got 6 rows, each equaling 111, what's the total value of the magic square of the sun?
666.
Now, have we ever heard of that number before?
Sounds familiar.
Yes, Book of Revelation. Here is wisdom, it says. Let him who hath understanding count the number of the beast, for it is the number of a man, 666. That's where it's most usually associated with that particular verse.
Right.
And it shows up in other places too, but you can see here that it's associated with this particular magic square. And the connection is not simply fortuitous. It actually, I think, helps to disclose the symbolic significance of that particular number. And there are other places where it shows up. And it's usually associated with evil.
Right.
But not always. See, and here's the thing, and this was the work where the late John Michel showed back, way back in the 60s and 70s, is that the number 666 frequently shows up in association with solar symbolism. In the same way that the number 1080 shows up frequently with lunar symbolism. And in his cosmological concepts, he saw that the lunar force and the solar force had to interact in certain ways in order to produce an outcome, which if you add those together, those two numbers, you get 1,746, which is a number that has some very interesting significance to it. It was Luke 17, verse 20 in the New Testament. So this was Jesus speaking, right? The Greek, Jesus, right? For verily I say unto you, If ye have faith as a grain of mustard seed, ye shall say unto this mountain, remove hence to yonder place, and it shall remove, and nothing shall be impossible unto you. So now the Greek spelling of grain of mustard seed is kakos synapios. Kakos synapios. We'll save this for a future podcast, but you have Kappa, Omicron, Kappa, Kappa, Omicron, Sigma, final Sigma, Sigma, Iota, Nu, Alpha, Pi, Eta, Epsilon, Omicron, Omega, Sigma. That's how it's spelled. Now, like I said, we'll save this for another time, but the point being, and this opens up a whole nother branch of numerical symbolism, is that prior to the advent of the Hindu Arabic numeral system, long around, I guess, maybe the 5th, 6th century AD, somewhere in there, in the Semitic world, the Semitic alphabet served a dual purpose. They weren't just letters of the alphabet, they were also numerical values. So in the Greek alphabet, you had alpha, beta, gamma, delta, epsilon, digamma, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, omicron, pi, Copa or Kappa, Rho, Sigma, Tau, Upsilon, Phi, Chi, Psi, Omega. Now, each of those, starting with Alpha, had a value of 1. Beta had a value of 2. Gamma of 3. Delta 4. Epsilon 5. And then when you got up to Theta, that was 9. Iota had the value of 10. Then you get to the Kappa. It had the value of 20. Lambda was 30. Mu was 40. So if you can actually go into like a Greek New Testament, and you will see the chapter headings. Chapter 13 will be chapter Iota Gamma. So Iota is 10, Gamma is 3, right? This is how it worked. Then it was a variant of the Hebrew system, a denary system. If you went through the whole system, it basically went from 1 to 10, then by tens, 10 to 100, so 10, 20, 30, 40. Then once you got to 100, it went up by a factor of 10 again, so you then had hundreds. So, for example, Rho had the value of 100, Sigma had the value of 200, Tau 300, Upsilon 400, Phi or Phi was 500, Chi 600, Psi 700, Omega 800, etc. Then when you look at the Hebrew, you had which was actually the older system. The Greek was undoubtedly partially derivative from the Hebrew. You had Aleph was 1, Bet was 2, Gimel was 3, Dalet 4, He 5, Vav 6, Zion 7, until you get up to the Yud, and that was 10. Then you go to the Kaf, was 20, Lamet was 30, Mem 40, Nun 50, until you got up to the Kof, which was 100, Resh was 200, Sheen was 300, Tau was 400, and so on. So this is how the system worked. And basically, you also had an Arabic system that paralleled this. And I haven't studied this, but I understand that the Sanskrit was also used numerically. But what that means is when you go to some of the ancient writings, you could look at these strings of symbols, not just as letters, but as numbers, you see. So from that perspective, then, a word would be composed of symbols, and those symbols would each have numerical values, and then you could sum those numerical values, and you would get a numerical value for the word as a whole. Or it could be a name, or it could be a phrase, right?
Right.
So now, going back to this idea that I was talking about here, the grain of mustard seed, Synapios, you add those letters up, you get 1746. And 1746 was the number you get when you add the lunar number 1080 to the solar number 666. So then the question would become, well, and the skeptic and the reductionist will go, oh, well, that's just a coincidence.
Coincidence, right.
And if that was an isolated value, I would most likely agree with them. I would say that's a hell of an interesting coincidence. But yeah, that's all it is. It's a coincidence. If it was an isolated value, if it was an isolated example,
Right.
but I can assure you that it is not.
The other thing I noticed about the number 1746 is that the digits all add up to 18,
Which adds up to 9.
which those digits add up to 9. It's the same with all these processional numbers. We talk about that all the time.
Mm-hmm.
That's a really strange thing. I mean, it's
it is.
it's divisible. So I guess that means it's divisible by 9, I think, right?
Mm-hmm.
Yeah. That's just
And
really-
so here's another example. If we go to the Hebrew, in Hebrew Kabbalah and Hebrew invocatory magic, you had the angel who was the spirit of the sun. And he went by the name of Sorath, right? Sorath. Sorath was spelled Samek, Omicron. Samek, Vau, Resh, Tau. Samek, Vau, Resh, Tau. Samek in Hebrew had the value of 60. It was the letter S. So you had 60 was the first letter. It was a 4-letter word, Sorath, right? Then you had the Vau, which had the value of 6. You had the Resh, which had the value of 200. And then you had the Tau, which had the value of 400. So you've got Tau 400 plus Resh 200, 600, Samek 60, Vau 6. So there you go. There's your 666 is the number of the angel who was the spirit of the sun in the ancient Hebrew Kabbalistic system. So these are just two isolated examples of hundreds and hundreds of such examples that we could actually discuss here.
That's fascinating. Why is there this whole evil connotation? When did that come about, or what is?
Well,
is that a recent thing, or?
I think there's multiple reasons for that. For one, if you're looking like Satan, the whole idea of Satan, Satanan, where does that come from? Where does the idea of Lucifer come from? Where does the idea of where does this idea of evil come from? Who are the beast? Who is the beast? Was the beast Lucifer? Was the beast the devil? Was the beast Satan? Who was the who are the very other characters of evil? You know, you can't just interchange them. They're not perfectly interchangeable. They represent, and here's how you have to think about it. To me, you have to consider that these represent natural forces. Now, suppose you are living up somewhere within the Arctic Circle, and you get to see the sun, you know, a month or two every year, and consider your psychological orientation and your psychological relationship to the sun if you were living in the Arctic Circle. Now suppose you were stripped naked and dropped into the desert, you know, the Sahara Desert.
Yeah.
Now you'd have it wouldn't be the benevolent sun anymore, would it? It's the same damn force, isn't it?
Right. Yeah.
But it's all in your perspective. It's all in your relationship. And so that's part of it. The other part of it is, of course, anytime you have a new dominant religion, the gods of the old religion become the demons and the devils. And so if you had an older religion that was a solar-oriented religion who was, anthropomorphizing the sun, you know, now that becomes evil because we're trying to transfer this idea from your sun god to our sun god. So that's part of it. So if, you know, to a rational person, and I hope most of the listeners of this will have their rational faculties intact enough that they can look at these things without the distortions of superstition. because there's so much superstition around this kind of material that's come down to us that's really hindered our ability to understand what it is. And to realize is that it actually does represent a very sophisticated understanding of the universe and forces of nature. But this understanding has been codified in ways that we've kind of lost the translatory keys to. So it's just like, modern science is all based on symbolism, isn't it?
Yes.
And ancient science is based on symbolism.
Since they had a different set of symbols, and we lost those symbol sets in a lot of ways.
And all the modern scientists are like, those old symbols are evil.
Well, again, that's your superstition. That's
right.
People who have abrogated their rational faculties, their God-endowed power of reason, and have succumbed to superstition. And it's mostly just intellectual laziness that leads to that.
Yeah. So why is 666 the number of the sun? Like, is there a reason for that?
Well, that's a tough call.
Okay.
We would have to look in nature. The orbital speed of the Earth around the sun is 18.5 miles per second. Kyle, do your calculator. 18.5 miles per second times 3,600 seconds in an hour. To translate that into miles per hour.
Times 3,600.
3,600.
Number of seconds in an hour.
66,600.
Oh yeah.
That's it.
Miles per hour.
I can't remember if this is right, but something in my brain is telling me this is right. But the carbon atom, which all life is based on, has 6 neutrons, 6 protons, and 6 electrons. I think.
I told you this.
Oh, okay. You probably told me that.
I did.
Okay.
I introduced you to that idea that the carbon atom, the basis of all living things,
Yes.
has the number 666 associated with, because 6 protons, 6 neutrons, 6 electrons. There's a
that's
lot
right.
more to it than that.
The redemption of the beast. That's where I got that from. That's right.
Yeah, right. That's
right.
where I got that. Because that particular exposition on the role of carbon in nature, which people should read, because see what's happening now is carbon dioxide has become one of our modern demons.
Yes.
It's been demonized. And it's utterly essential for life. Without carbon dioxide, there's no photosynthesis. And without photosynthesis, we are effed big time.
That's right. The basis of the food chain.
Screwed.
Yeah.
But, there's so many misconceptions about carbon dioxide and its role in nature. It has the dual role. It's a greenhouse gas. It's also the key to photosynthesis. But its function as a greenhouse gas, and here's the point, it's very limited. In fact, carbon dioxide's thermal capture is pretty much all within the first 50 to 100 parts per million. And beyond that, the capture falls off logarithmically. It decays really rapidly. So the computer modelers, what they do is they have to introduce positive feedback amplification, because they know that carbon dioxide is already pretty much saturated, in the sense that the capture window that carbon dioxide operates in is 14 to 16 micrometers. Micrometers or microns, right? And what happens is, once that window is capturing all of the heat that it can capture, it ain't going to capture no more. See?
Right.
But what has to happen here is that in order to make carbon dioxide look like a demon that's threatening our existence on Earth, is it has to trigger this cascading effect, this cascading amplification through positive feedbacks. And this is done generally through water vapor. Water vapor now becomes the ally of carbon dioxide in the computer models. So the idea is that carbon dioxide ramps up the heat a little bit. The heat now causes more evapotranspiration, which introduces more water into the atmosphere. And of course, water vapor is far and away the dominant greenhouse gas. But it's also very active in that same 14 to 16 micron wavelength. See, so the thing is that it's like a ping pong. Okay, so a little bit of carbon dioxide added to the atmosphere, and it is a little bit. We're talking about since the Industrial Revolution began, we're talking about a little more than 100 parts per million.
Yeah.
Per million. That ain't a whole lot. Okay. But the point is that 100 parts per million is now supposed to ramp up global temperature enough that more water vapor is now introduced into the atmosphere through evaporation. And that now causes further warming, which then causes more carbon dioxide theoretically to outgas from the oceans, so now it's back and forth. See?
Yeah.
The problem is this is a highly oversimplified variation on what really happens, because more water vapor produces clouds, and there's a lot of evidence to suggest that clouds have a net cooling effect on the lower troposphere. So, there are plenty of legitimate questions to be asked about the claims being made of carbon dioxide induced demonic doomsday.
Right. I mean, like you can easily see that enormous amounts of clouds raise the overall albedo of the planet, which means it's reflecting more light back out into space, which, I mean... Yeah.
And cooling. I mean,
that
imagine
causes
you're
cooling.
you're out there in the hot sun, and then a cloud goes over the sun. You instantly can feel the cooling.
Yeah, you're like, it's much better.
Yeah. So if you have more clouds, generally, you're going to have more cooling. Not always, but the net effect, that's the important thing. So you see, the doomsday predictions all are based upon computer models, not so much the empirical data. In fact, the empirical data is constantly being adjusted to conform to the computer models.
Yeah.
Which is ass backwards.
Right. Wrong way, scientists.
And people don't realize that. It's just frustrating to me that the media is just beating this thing to death. Every single weather extreme that was once considered completely normal a generation or two ago is now proof.
Yeah.
It's now proof. But you got a high pressure system that stalls over the Midwest for 4 or 5 days, like we did a while back, that created this, right? Well, that's a perfectly normal thing. It's a perfectly normal thing to have temperature inversions, to have high pressure zones that get stalled for a while, and then you have a heat wave. Heat waves are normal parts of the natural order, and yes, sometimes heat waves can be very hot, just like cold spells can be very cold. But when we look at the big picture of climate change and global change, nothing that has happened in our lifetimes is outside the bounds of what has been going on for thousands and millions of years.
Right. Not even close. If you look at the ice core data for what was going on before the Holocene, it was wobbling all over the place, right?
It was wobbling all over the place. Huge shifts of 10 degrees centigrade in a matter of a few years.
Yeah, that's terrifying.
That really did happen.
Yeah.
And why did it happen? Well, we hadn't figured it out yet. So somebody comes to me and says, well, there's a consensus. The science is settled, No, we haven't even begun to understand the complex dynamical system of the global climate,
right?
And all of the factors that are influencing it. And I will say right out that I think the weight of the evidence shows that the 20th century warming is solar related, much more so than carbon dioxide.
It does seem solar related.
Yeah, absolutely. And see, right from the beginning,
that's it. It's evil, man. 666.
It's the sun. It's killing everyone.
You see, in a way, I digressed into all this because it almost is sort of a modern incarnation of this kind of superstition. See, and so what has happened now is, the scientists, the infallible scientists, right? It's almost like, remember the infallibility of the Pope?
Yeah.
Now it's the infallibility of the IPCC scientists.
Right. They speak from authority. Yeah.
Right. And you don't question, oh, well, that Randall Carlson, he doesn't have any credentials. Well, what credentials do you need? I'll put it this way. I got obsessed and fascinated with the weather when I was probably 10 or 11 years old, and have never ceased to be obsessively interested in climate and weather and all of that since then. So, you spend 40 or 50 years studying a subject, observing nature, you can come to some pretty valid conclusions.
Yeah.
And as Brad can testify, I've read thousands of scientific articles, of which hundreds of them deal directly with the question of global change. And so I know myself that, there's plenty of dissenting viewpoints out there.
Right.
And so
there is no consensus on this stuff. It's just
it's a manufactured consensus, because the idea at the very beginning, at the very outset, anybody has to do is go read the friggin' charter of the IPCC. It's go demonstrate that humans are causing climate change.
Yeah.
And so that's what they're doing. And guess what? Humans are causing climate change. Nobody's denying that. But the question is how much compared to the natural forces?
Right.
The assumption now is that it's all due to humans. And any person who would say that, I would then ask, well, so you're saying that whatever was driving climate change before the Industrial Revolution, all of those natural forces are now turned off and non-operational? Is that what you're actually saying?
Yeah, or overwhelmed by human influence somehow.
Right.
Yeah.
Right.
Yeah.
And then people from there say, well, and I've gotten this all the time. Well, we want to stop pollution. We don't want to, we want clean air and water. And I agree with you 100%.
Yeah.
Right. Pollution is one thing, right? Carbon dioxide is not pollution.
Yeah.
In fact, all you got to do is, every time you exhale, you're breathing out carbon dioxide.
That's right. Killing the planet.
Plant food. It's not pollution.
Because of your articles, Redemption of the Beast, I actually started up a CO2 greenhouse project, and it went fantastic.
Really?
I sealed off a little area outside, got some grow lights, got some CO2 tanks, and got myself a CO2, a meter, a ppm meter, and kept it at 1,200 ppms during the day when the grow lights were on, and those plants went crazy in there. They loved it. Yeah,
they do. They love it. That's why we're in the midst of a greening of the earth.
That's right. That's right.
Yeah. And since I wrote The Redemption of the Beast, 2 or 3 years ago, there's been a lot more evidence that's come out confirming that, we're experiencing, the planet is undergoing a greening.
That's right.
And
Deserts are shrinking.
Yeah. Deserts are shrinking. I remember when I made that comment on Joe Rogan a few years ago, somebody went on and said, well, everybody knows that the deserts are expanding. Everybody knows that. Like, it's just a given. Well, that's part of the religious dogma that you have accepted on faith. And so you believe that. But what does the actual evidence show us? You see?
Yeah. That's right.
So I didn't mean to necessarily get off on that, but
you got to have this is
of some of the themes and the ideas. The idea that carbon dioxide has now been demonized.
Right. This is Brothers of the Serpent podcast. We can't have a podcast without at least one good rant. So
okay,
this is like it's like a rule. So
okay, so I'm in my element here.
That's right. Randall Carlson rants are the best. That's what I got to say.
What did we used to call them? When we were on our trips and we'd be holed up in some sleazy hotel room or something, and I would do a Randall log.
There you go, Randall log. That's what it was.
Randall log.
All right, so let's talk about what the other project we're working on. Since I think we're coming up here on time.
Yeah, I think so.
And you guys need to get to bed, Brad.
I need to get to bed. Yeah.
Yeah. So
Brad's already asleep.
Brad's passed out. So what we've been doing. So we actually were able to go. We went to the contacted the cabin 2019 up to Mesa Verde. We went to Mesa Verde. We were in Colorado. So we met each other and we hit it off. And now we've all sort of put this thing together, and we're doing an actual Randall Carlson podcast called Cosmographia. And so we've actually recorded how many? 5?
5 episodes.
Yeah, so we've got 5 episodes in the can, people. That's what we're trying to get all the logistics together and get all that. But got to get the websites up and everything. But we've been moving ahead with actually recording the material, and it is great material. It will be both video and audio podcast, so it'll be available as an audio podcast everywhere you can get podcasts, iTunes, Stitcher, Google Play, all that stuff. We're still working on that part of it, but we have the videos available, and I think Brad was saying that he'll be able to publish episode 1 on YouTube on the Cosmographia YouTube channel tomorrow. Is that right, Brad?
Yeah, we want to spin it out on 8/8.
That's right. There we go.
Tomorrow,
August
tomorrow.
8th.
That's right. August 8th.
So that sounds like a good launch pad.
Right. So the YouTube version of the episode 1 of Cosmographia podcast with Randall Carlson and, of course, us and Brad will be available on YouTube tomorrow at the Cosmographia channel. That's where you can find it. And we're still working on getting the audio version, your regular RSS podcast feed set up, but that should be available within a week or 2.
I know nothing about this.
Yeah,
I'm sound guy and also one chair.
Initially, it's going to be on the Geocosmic Rex YouTube channel.
Oh, okay. We don't have a Cosmographia YouTube channel yet?
This is going to be the first thing there, yes.
Okay.
Absolutely.
All right. Yeah, so it'll be available on Geocosmic Rex, the YouTube channel, and it'll also show up. We'll have a Cosmographia YouTube channel too, and it'll be there.
That's right.
Right.
It'll be there right also after.
Right. So we've been doing these podcasts basically using a video conferencing system. And so Randall's doing screen shares, and we're recording the whole thing as video, also recording it as audio. And then Brad is taking the video and sort of sprucing them up a bit, and that's what he's going to publish. And we are taking the audio and sprucing that up a bit, and that's what we are going to publish as soon as we get the RSS feed stuff set up and lined out. So,
yep, and we're all remote, so
yeah,
all in different places. This is it's been an interesting challenge to kind of get it all the kinks ironed out, and we're still working on it. And eventually, like we're going to be looking into getting better and better software
and
to
equipment,
and equipment to make it more streamlined, more better quality audio, better quality video. But we're going with what we got right now, and it's all about the content.
Right.
It's fantastic content. So
that's right. It's been fun, and there's been a lot of extraordinary content. Thank you, Randall.
That's right.
Yeah.
It's
well, thank you, Bradley. Thank you, Bradley, for being such a great associate all these years. I don't know if I could have done this without you, Brad.
Yep. That's what I think too.
You might be on the side of the road hitchhiking still.
I probably would be, yep.
Well, that's a story for the
podcast. Cosmographia, I will just mention, it kind of covers a lot of the things like geology and astronomy, and we will be looking at archaeology and paleontology, and that will kind of be more of our focus here. We'll be looking at ancient cultures, of course. I'm going to be doing also some podcasts with my buddy Cameron Wiltshire, and that will be more of an emphasis on the geometry and the architecture and things, although there'll be some overlap,
right?
Of course, because you can't take this material and break it up into nice, neat categories. But Cameron's been putting together a series of podcasts we're going to do called Gnosis, and that will be a lot more of the kind of thing that we were talking about here tonight with the numbers, the Kabbalistic stuff, how it relates to art and architecture and that kind of thing, because it's going to be kind of going through the Sacred Geometry website.
Yeah.
So that's going to be coming, and that will be a nice complement to what we're going to do here.
Right.
And hopefully I can pull it all off.
Yeah.
Make it all work. And still finish my book by the end of the year.
Yeah, when's the book coming out? Tell us about the moon!
A book.
Oh, man. Well,
Get it
You
from
know,
all
what makes
angles.
this nice is for me is I can sit here right in front of my computer in my office here, and I don't have to like spend 2 days driving to get somewhere, and
Yeah.
which of course I don't mind doing, but
Hell yeah, technology.
That's right.
Yeah. So that, speaking of that, the other thing in the works, since Randall, you and Brad have gone on many trips together and plan to do many trips in the future, we're going to be working on doing more trips similar to the Contact at the Cabin, that are organized, that people can join in, buy tickets or rooms to stay in with us and go and tour the sites with Randall and Brad and learn the whole time, get to see some slideshows, all of that. So
Right.
that's also in the works.
That's definitely on the docket.
Yes.
Yeah.
I'd love to get out and show these places. It's incredible once you really see it from the ground in the field.
Right. And even do like new field work too, like not just go to places where you guys are familiar with, but also assist Randall and people can assist, and those will probably be smaller groups. You want a smaller group to manageable and get out into new areas that Randall hasn't looked at yet and actually participate in the research.
yeah, because one of the things I've realized is that in spite of all the places we have visited in the last 22 years, all of those places, there's still more places that we haven't seen.
That's right.
Totally.
Damn universe, it's freaking big.
Yeah. So
Start out with the planet.
and the way that we'd probably structure them is like, for example, if we were going to do the great floodlands of the Pacific Northwest, we'd want to do at least a week. We'd probably want to do a smaller group
Yeah.
because Contact at the Cabin in Colorado was 75 people. So that was, and plus it was rushed. I would prefer not to rush it. I would rather have a full week where people can really absorb. But then also leading up to the excursions, we could do, or we will be doing podcasts and giving people reading assignments.
Right.
So that anybody who is actually going to participate doesn't walk in completely green. They know where we're going, what our objectives are, what we're trying to accomplish. And of course, their own experience of it will be much more enriched the more they know about, what we're doing, what we're looking at. And, to learn the terminology, for example, so that when we're out in the field, I don't have to necessarily stop and explain to somebody the difference between a terminal moraine and a lateral moraine, or a diamict, or a cross-bedding, or a valley train, because
Or a squigliosity.
they've already seen those. They've seen pictures of them. They've heard us talking about those, so they know what it is. Once we get out in the field, that way we can make
much more progress.
Exactly.
Yeah.
Exactly.
Right. And so the one other thing we need to bring up here is that in conjunction with the new Cosmographia podcast with Randall and the websites that we're building and everything, is also going to be a way to support Randall and his research, both to help us get better software and equipment for the podcast to make it higher quality, and in the end, really to help Randall get out in the field more often and do better research, get equipment for the research, and be able to pay to stay places and travel and everything like that, and cover expenses. So we're setting up, we've got a Patreon set up that is associated with the podcast. So that Patreon, anybody supporting that will be basically supporting the podcast and Randall and his research. And there will also be donation, like single donation abilities. All this will be on the website eventually. But so we're just basically, the point of this now is to announce that this is happening. And of course, the first episode will be published tomorrow on Geocosmic Rex, and hopefully also the Cosmographia channel.
And Cosmographia with a K.
Nice.
That's right.
With the K.
And you should mention, as Brad has commented, it really seems that since we've been doing this now and connecting with folks, talented folks and interested folks around that have a lot of different skills, it seems that a team is sort of emerging from this that our combined efforts could be very synergistic and really help to move this to the next level.
Yes, absolutely.
That's right.
Yeah. So
that's right. And
Very
so
exciting stuff.
That's right. And all the listeners of the podcast of the Cosmographia podcast, especially any supporters through the Patreon or PayPal, will be part of that team because the support is very important for Randall to actually be able to get out more in the field and do more of what everyone wants him to do, which is find out crazy stuff to come back and tell us about on the podcast. Right? So this is the idea.
Nice.
yeah, okay. It's good to me, man.
2 hours later, yeah. More podcast.
That's right. More podcasting. Come on.
Excellent. Excellent.
All right, guys. Well, this has been a blast. Thank you so much for sticking around, especially you, Randall. That material was fantastic. So,
all right. Well, good.
Wanted to say thank you, man.
There'll be a lot more of that. I mean, we'll cover some of that here for sure.
Yes.
But there will be a lot more of that kind of stuff over on the Gnosis podcast with Cameron.
Right.
Excellent. Sign me up.
That's right. So, yeah, that's right.
Right.
Check out the Gnosis podcast as well when that comes out. All right, guys. Thank you so much.
All right. I guess be talking to you guys next Monday.
That's right.
Snake Bros.
Snakes.
Bradley.
Bradley.
All right. All right.
I'd see you, Randall.
All right, Brad.
Good
So
night,
long.
guys.
All right. That was awesome.
That was amazing. Second podcast with Randall Carlson, but actually our third interview on this podcast because the first podcast actually was 2 interviews.
That's
podcast
right.
with Randall Carlson on one show. Anyway, you guys can get a hold of us, brothersoftheserpent@gmail.com, the website, brothersoftheserpent.com, where you can find pretty much everything about us there. Comment there. Check out the encyclopedia, the Snake Bros Glossary, or the Snakelicon.
Yep. Talk to us on Twitter at Snake Bros with no vowels, SNKBRS. Share the shows. Donate to our pyramid scheme.
That's right. Also, you can go to Patreon, patreon.com/Brothers of the Serpent to donate there. We have a couple. Thank you, Laser Printer Jam, for upping your donations, buddy. Man, you're awesome. Thank you so much.
Yeah.
And also, Robert.
Thanks, everyone.
Yeah.
For
all the
your
donations. Thank you guys so much.
Appreciate it.
Yeah, and the reviews. I read some reviews earlier. Give us reviews on the iTunes, and I will read your comments if you put them in there because we love them. Warms and fuzzies. So.
All right. It's time.
Cracking that tall boy.
All right. Thanks to History Shift for all the hard work, man. Unbelievable.
Yeah. All the videos.
Yeah.
So you can check us out on Brothers of the Serpent channel on YouTube because of all of History Shift's work. Brandon Ricks. You can follow him on Twitter at History Shift. Also, he's got a blog, historyshift.com, where he
The saga, man. What's the saga?
The saga. The history shifting saga of him finding dolmens and glacial erratics in northern Montana. I don't actually know that he's in northern Montana. He's in Montana. Big place.
Don't talk to me, man.
Also, Henry Hablack, awesome artist, sent us a bunch of stuff we got hanging up in the cube here. Check him out at HHablack on Instagram. He's also got a website, hermetica.bigcartel.com, so check him out. Thanks to Henry for all the swag he sent us decorating the Tangent Cube.
Yeah. Thanks, everybody.
That's right. We love all you guys. Thanks so much. Hope you enjoyed this Randall Carlson episode. Good night, Adamu 666. Randall Carlson.